Hello everyone, I am Someshri Chanapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So today we will continue a structural analysis class from whether the structure is statically determinate versus statically indeterminate. So how to know that statically determinate structures have reactions and internal forces solvable that will be solved using equilibrium equations alone with unknowns equal to equations. Like these are very long lines. If we just simplify this, we just need to know in case of any kind of structure that must be the equation of equilibrium must be equals to the number of unknown. So what are the unknown? What is equation of equilibrium? Equation of equilibrium we have understood from our previous classes. So what are the unknown? First thing we are discussing here about statically determinate structure and indeterminate structure. What are the structures? Let's understand that whenever as a civil engineer we talk about structures, we have three types of structure in our mind, that is one beams, another one is frame and another one is your truss. So the beam, frame and truss that are statically determinate or statically indeterminate, we will understand from where? From equation of equilibrium and the number of unknown. So here it says that indeterminate structures have more unknown reaction that members are equilibrium equations. Okay. So let's understand for first beam. First we will understand what is beam, then we will go for that the beam is structurally or statically determinate or indeterminate. A beam is single structural member that is designed primarily to resist transverse load. A single structural member. Okay. I can say another point, single horizontal member. A beam is a structural member with what? One horizontal member. Because whenever we have the vertical structure, that is called as column. Okay. So the single structural member or horizontal member designed primarily to resist transverse loads. To resist what? Transverse load. Transverse means what? That load acting perpendicular to its axis. We will understand that. So, if we just draw a single line, that is going to be a beam. If we just a box, or you can say a rectangular box, so that is also a beam. So to sustain the load of beam, we need what? We need supports. We already discussed this support and reactions in our previous classes. So I just need to remind what are the supports. The supports can be four types. We have supports like pin, or you can say hinge. Another is your roller. Another is fix. Whenever we have structures, we need supports to handle the structure. Okay. So the structure, the supports can be pin or hinge, roller, or you can say fix. The pin or hinge support, these supports have reactions. Okay. How can we? Like when we have pin or hinge support, So the structure cannot resist. We have to think about the load in which direction? In vertical direction, in horizontal direction, or that can be rotation, or you can say movement. If the support can resist those type of loads or reactions, then from that only we can calculate the reactions. We have already discussed these things. So for now, in case of hinge support, we have two reactions. Okay, just need to remember. In case of roller support, we can have one reaction, and in case of fixed support, we will have three reactions. Okay, so let's draw the diagram. In case of we have a pin support or hinge support, that will be drawn as like this. If we have a roller support, we will draw the support like this, and if it is a fixed support, it will be drawn like this. Okay. Another thing we need to remember for a second, like equation of equilibrium. If any structure supports or satisfies that summation of all the loads in vertical direction must be 0. Summation of all the load in horizontal direction, that must be 0. Summation of all the moment must be 0. Then it satisfies equation of equilibrium. So equation of equilibrium, we can say that it is 3. The number of equation of equilibrium is 3. Let's draw a beam. So first we will draw type of support. So here I draw a hinge support with a roller support, and I give here one point load, another point load. Let the span is L. So now how can you know whether this beam, let this beam as A, B, this beam is statically determinate or indeterminate. So how to know that? We know that we will first calculate the unknown. So in AB beam, what is the unknown? We need to find out. Here we have the span, the beam span or the beam length as L. We can put 1, 2, 3, 4 any. So, and here we have the load as P1 or P2. Now what is the unknown? The unknown is nothing but your reaction. So we have already discussed like this. In case of hinge support, how many reaction will be generated? In case of vertical, 1, in horizontal, 1. So here for this support we will have 2 reaction, and for roller support we will have one reaction. So 2 plus 1 as 3. Whenever we solve the beam statically determinate or indeterminate, we need to know the equation of statics. That is, equation of static is nothing more than equation of equilibrium, because In case of statics, we doesn't consider this thing. We will not consider this because beam cannot handle the horizontal load. Only beam can tolerate the vertical load and rotation. So, in case of beam, we will solve the equation with equation of statics, that is summation of vertical force equals to 0 and summation of moments equals to 0. Okay. So, here the number of equation is 2, right? So, in case of equation of statics, we generally doesn't consider equation of statics because equation of equilibrium is both for beam case and frame case. Okay. So, here as the equation here becomes 3 and we have the equation of equilibrium as 3. So, this structure will be a statically determinate structure. Okay. Also, if we have one support as roller and another one as hinge, so this is also called as a simply supported beam. Okay. The next we will draw another structure. So first we will draw a beam, that is AB, and we will just put one fixed support here and give a half span UDL. Okay. So now this AB's beam is statically determinate, or so how to know that? From fixed beam we can say this has 3 reactions in case of vertical, in horizontal, also in rotation. So here the unknown equals to 3 and we can say the equation is 3. So this structure is a statically determinate one. Okay. Similarly, if we have a fixed beam, or we can say a fixed support at one end and free end, so this type of beam we can say it is a cantilever beam. What? It is a cantilever beam. The previous one is a simply supported beam. Okay. If we have one hinge support and one roller support, that beam is called as simply supported beam. What? In case of one hinge and one roller. Cantilever is one fix. Now we will discuss another kind of structure, like if we have one hinge support and another is one roller support. The easiest thing here in our whole civil engineering, we will discuss only about three types of support. So no more different kind of support. Another one is a link, but generally we don't put link support in case of numericals. So one is your fix, hinge and roller. Okay. So this type of beam, here you can see we have A, B, and this end we have C and D. Let this A, B has UDL. The whole span is L. So you can see this part of beam is hang. So in this type of beam, we will say this is a overhanging beam. So one question must be in your mind that the reaction must be more in case of overhanging beam. No, the reaction only depends on your supports. Whenever we think about reaction, the reaction only depends on the type of support you have. Like here you have the hinge support, that will reaction 2, that will give you 2 reaction, and the roller support will give you 1 reaction. So here also unknown equals to 3 and equation equals to 3. This is a also statically determinate structure. Okay, we have discussed that statically determinate, statically indeterminate we never discussed. So let's go for that. If we have a beam like here, we have the beam as ABCD. In case of ABCD, the number of unknown is equals to what? Here, in case of fix, we know that the reaction will be 3, and for hinge support 1, 1, 1 in vertical direction, and so here the number of reaction is 3 and here 2, 2, 2. 6 plus 3 as 9, but we have the equation as equation equals to 3. So this structure is a statically indeterminate structure. Okay. Here we have shown statically determinate and indeterminate both type of beam. Let's go for a frame structure. So what is a frame? In simple word, I just make sure you understand properly that a combination of beam and column that can make a frame. What it says? like a complex structure of beam and column connected by rigid joints. Okay, if we have beam and column, so it must be a joint, that is the what? Rigid joint. So these joint transfer bending moment between members. These joints will transfer what? Bending moments between members, allowing the structure to act as a single unit. So what will happen? Whenever it has load, it will transfer to column. So this transfer will done by this rigid joint. So this structure must be act as a single unit. Frames are common in multi-story building and industrial workshop. Whenever we make a building, so what we do does, like first we need to prepare foundations, then we put columns, then we make beam. So these beam and columns are jointed by what? Some rigid joints, so that it can be transferred the load. First beam will transfer the load to what? Column. Then these columns will transfer the load to what? To foundations. Okay, so this is the property of any kind of structures we have. Whenever we make a building or bridge or anything, the property is it transfers the load. It cannot the load take the load on single unit. So it transfers the load to beam, transfers the load to column, column transfers the load to foundation. And again also foundation will transfer the load to soil. So in case of structure we don't need these things. So we just need to know that a structure, or you can say what is a frame. The frame must be a connection of beam and column. If we connect like this, and this is also a frame, this is also a frame. But again we will come to the point that any structure need what? Support. So we need to put what? Supports. The supports must be a hinge, roller, or you can say hicks. So here you can see that this frame structure is having two type of support. One is hinge and another one is roller. So as we have understood in case of beam, the similar way here also. In case of hinge we will have two reaction, and in case of roller we will have one reaction. So this structure is a statically determinate one. Statically determinate structure. As I have drawn here like this. So if we have hinge, all the hinge supports, so this structure is A, B, C, D, E, and it is connected with beams. Okay. So here we will have how many number of, we need to count what? The unknowns. We will have two reaction at each support. Right. We will have two reactions at each support. So here we will have the unknown as 10 and equation of equilibrium is 3. So you can say in comment section that what kind of structure is it. Okay. I have drawn this frame. This is your frame 2. You will make sure the answer what kind of structure it is. Okay. We have discussed beam. We have discussed frame. Now we will go for another kind of structure, that is your truss. Truss is a what? A framework of straight members joined at nodes to form triangles. Generally, we have truss in case of bridges, railway bridge, or you can say national highway bridge. In case of bridge, we will have truss because the joint are assumed to be pinned. Okay, so members do not experience bending or shear. Trusses are highly efficient for spanning large distances over 18 meters. Like for very long or large structures, we will make sure there will be a truss. It can take more load than compared to beam and frame because they use less material than solid beam. So why we make sure the truss is formed, that it is efficient for spanning large distance. If we have a bigger structure, we will prefer what? A truss. So this is the diagram for a truss. But in case of truss, we will not need what? Your equation of equilibrium, because it has different formula. Whenever we think about truss, it will have different formula that okay, m equals to 2j minus 3. What is m? What is j? 3 you can say for equation of equilibrium we have taken this, but we don't need the analysis. We don't need here why m equals to 2j minus 3. We don't need to know. We just need to know whether the truss is statically determinate or indeterminate, and in everywhere this formula is here. So m equals to what? The number of members. For the number of members, and your j is equals to number of joints. Now we will go for counting the number of members and the number of joints. So number of members, here you can see this each one is a member. So I will just write 1, 2, 3, 4, 5, 6. Okay, I have end here with 21. So you will ask why ma'am is doing this. No, if we just forget one member, the whole structure will be in problem. So we need to count each of the members. We have member here as 21. Now what are the joints? So the joints here, the joints are like every node 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 1. Okay, we have end with 12. So your J is equals to 12. Now the formula is M equals to 2J minus 3. M equals to 21. 2 into J as 24 minus 3, that is 21. As here M is equal to 2J minus 3 satisfies. So this truss is a statically determinate. One. Okay. Now here is your another kind of truss. The first we will write the formula that 2J minus 3 M equals to 2J minus 3. Let's count the members as again here the number of member is 21. Okay, and what the number of nodes is 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Same as J equals to 12. So here also M equals to 2J minus 3. So it also satisfies. That does mean it is a statically determinate structure. Okay. So here another type of truss is, you can say, like it is a vertical truss. So the members, so if you confuse like what are the members if this has a node. Okay, if this has a node, then you will count 1, 2, 3, 4. Okay, but in case that because of that we never calculate the, okay, we never calculate the members first. First we need to calculate the joints. Okay, so if we have the joints here 1, 2, 3, 4, 5, 6, 7, 8. If these are not the joints, then we will calculate the members like 1, 2, 3. J equals to 8 here. So these members will be calculated, these as 1 and here are 2. If we have a node here or joint here, then the number of member will be 1, 2, 3, 4. Okay, understand? So here we don't have the node point. So the members are 1 and 2. Okay, 3, 4, 5, 6, 7, 8, 16. Member is your 16. So now how to know that whether the number of member will be same or different. So you will consider this as single member if it doesn't have a node here. In case of exam, if exam has this type of question, so this will put like node. Okay, the nodes are shown properly. So now the structure is a statically determinate or indeterminate. How to know that the (16) 2j minus 3, that is 16 minus 3, that is 13. So here the structure is statically indeterminate. Okay. Here I have another truss. So if you are watching my video, I have a question for you. You need to count the number of member, the number of joints, and will say whether the figure 4 is a determinate or indeterminate one. So I will end this video with this. In our next class, we will start analyzing a structure. Okay, thank you.